Hey, Comrade. So this is a Comrade's Lab 2, and this is our setup. So let me take you here first to the Edge unit. Right, as you can see, we have the Arduino right here, the ESP Wi-Fi module right here, and the XB as well. So our Mac Sniffer is working, which we will show in another video, but right now we're unable to get the number of MAC addresses to the XB to send. So what we're doing here is we're just sending random numbers between 0 to 56 through the XB, of course, to the router, which is right over here.
Okay, so this is the router. This is the router XB, and this is the Arduino, and it's connected to the gas sensor. And this is receiving random numbers from the Edge unit. And so you can see these are, the number of MAC addresses right now is random. That's the one that you can see, and that's what that is. And then the 24 ppm is the current gas sensor reading. If I put my hand over the gas sensor, you can see that the reading shoots up. So right now it's 47 ppm. And now it's probably going to be back in a little bit. Yeah, so it's back to 26. So what I want to do is like compare, like show you that both of these have like the same number of MAC addresses. So right now, as you can see, 81 just got sent over there, 81, 210, 022, and like over here, as you can see, there was 81, 22, 12, 9, 197. So yeah, so that works. And now, what's happening is there is a packet that's constructed from the gas sensor reading, and we append the MAC addresses to it, and we send it over to the Raspberry Pi, which Mike will now talk about.
So
That's the coordinator right over there.
Coordinator, we have it hooked up via USB through the breadboard because, as discussed on Discord, the Digimesh kit that we bought has 2 through-hole Zigbees and 1 surface-mounted Zigbee, and so we have the surface-mounted Zigbee connected to the dev board and hooked up to the Pi via the USB, and this is serving as the coordinator node in the Zigbee network. So to actually go ahead and parse the Zigbee packets, we take the Zigbee packet payload and we parse that based on a arbitrary specification we have for how to lay out the bytes. We'll go in more detail in the report and how that's laid out. But so for every Zigbee message, the payload can have multiple sensor readings. So like Tommy was saying before, the router sends 2 sensor readings within 1 Zigbee payload. So if we go ahead and look here, for our coordinator and the web server, we have 1 Python process that's just continually polling for Zigbee messages. And we can see for each sensor reading, we have a unique identifier, which in this case is just a serial number of the Zigbee module. The sensor reading itself, we have a sensor type, which is just like a enum type specifying if it's the gas sensor or the MAC addresses. So you can see the 1 is for the gas sensor, the 4 is the number of MAC addresses we're getting. We can see that the gas sensor is not changing as much, but the MAC addresses are changing more often because we have just random number generator. And then we have a sequence number, but that's currently not being used right now. We're hoping to extend that in the future. And then we have another process which is serving the Flask server. So when we go ahead and get the coordinator messages, instead of just printing it out, we also have a local MySQL database hosted on the Pi itself. And every time we go ahead and get a reading on the, we parse a Zigbee message, we go ahead and make insert statements into that database, and our web server will go ahead and query that database at when the client requests it. And for the locations of the sensors, we have a separate table where we store basically this identifier to where the current location of the sensors are. So currently, I've set up so all of the sensors we have now are within CBOL 1404, and we can see if we go ahead and open up our web server to display 1404, we see that these are getting updated, and because they're currently reading from the most recent value from here, and Vivek will talk more about the polling and how that's working.
So this is a web page, and this is how the user will query the data. As you can see, this is the personal air quality data and the most recent number of MAC addresses, which are randomized. And the way we are doing it, we are sending AJAX requests, which poll the database continuously every 1 second. And yeah, so this is how the web page is working. We are this is set up on a Flash server, which renders the whole template. This is the web page, and also provides the directory for the statistics through which the AJAX requests are polling through.
All right. So we can also do an end-to-end demonstration of like of the MAC addresses as well as like the gas sensor data. So we can all just pull the computers together. Yeah, you should probably just careful. Yeah. Okay. So.
The thing is, it's kind of out of order.
What?
It's a bit out of order.
Yeah, it's kind of out of order,
Yeah, we go
but
here, then there.
that's fine. Okay, so this is the end unit, and this is what you're getting right now. This is the coordinator. So the way the communication works is like it goes from here to there and then all the way over to there. So stuff that's happening over here should technically show up over here like soon enough. And as you can see, that is actually happening because you see that you got 219 and then you got 219. And so, yep, that works. And as for the ppm data, so this is like almost consistently 24, and as we move out over here, it's also like, yeah, basically 24. Okay.
Yeah, you can also see from Flask all the REST API requests we're making.
We can also just like have the web page pulled up.
Yeah.
That would probably be like a lot easier for like visual demonstration. So yeah, so that's 24, the air quality, and then the person count is the MAC addresses.
And if we like change touching the air quality.
Yeah, so
sensor, we
he's
can
touching
see
the air quality
the
sensor.
air quality would change on
And
the web
it
page.
definitely goes up. All right. So that was our project. And other details will be in the report. Thank you. Bye.